So, we now want to see about factoring quadratic expressions. A quadratic is any expression which has a square as its highest power, something like x squared plus 8x plus 12. And you've seen these several times when we've been practicing FOIL. You know that when you expand two parentheses multiplied together, x plus one thing times x plus another thing, we end up with a quadratic. If you use FOIL, x times x is x squared, x times plus 2 gives you plus 2x. Inner terms is plus 6 times x, giving plus 6x. And last terms plus 6 times plus 2, giving us plus 12. Collecting middle terms together, because they're both some quantity of x, you combine those, you get x squared plus 8x plus 12, the expression I put at the top. If we write that in reverse, x squared plus 8x plus 12, split the two middle parts into plus 2x and plus 6x, and we get x plus 6x plus 2, but we didn't have anything that told us what to split this into. Was it going to be plus 2x plus 6x or plus 3x plus 5x? How can we tell how to split it, and how do we then move from these four terms to the product of two expressions? So we need to have some common language for all of this stuff. And the first important word for you is the word coefficient. The quadratic has an x squared part, an x part, and a purely number part, and the coefficient of each of those terms is the number that's associated with it. So the coefficient of x squared is the number multiplying x squared. The coefficient of x squared here is 3. The coefficient of x would then be 8. And what's called the constant coefficient, that is the coefficient that has no x involved at all. It's a constant number, it never changes, whereas the value of this will change if we change x. The value of this will always be just 12. The constant is 12. If there is a term missing altogether, then that has a coefficient of 0, and if we don't have a number written before the x or the x squared, then the coefficient would be 1. So here the coefficient of x squared is just 1. We have one lot of x squared. The coefficient of x here is 7, and the constant coefficient in this particular example is 0. We don't say that there isn't one, we say that it has a value 0. Now we also want to name each of the coefficients. These are standard letters that get used by pretty much everybody for quadratic equations. So if I talk about a, b, and c, a is always the coefficient of x squared, b is always the coefficient of x, and c is always the constant coefficient. It doesn't matter what order the terms were written in, it's the job that the coefficients do that tells us what they are. So in this one, the coefficient of x squared is a, so a equals 3. The coefficient of x is 8 plus 8, so the coefficient of b is 8, and the constant coefficient is plus 12. The sign really matters here. Okay, I've written them in black, but this is plus 8, this is plus 12, positive 12. In this example here, don't be fooled because everything has been written in a strange order. A is the coefficient of x squared, wherever that happens to be. So how much x squared have we got? We have plus 7x squared, so a equals 7, positive 7. B is the coefficient of x. How much x do we have? And the answer is positive 3. And c is the constant coefficient. How much just number part do we have that has no x involved at all? And that is here, so c is negative 2. Now we've named everything, we can start using these to break up a quadratic expression and factor it. This is quite a long process, but I'm going to go through it step by step, and with a bit of luck, you'll be able to follow along and then replicate it in other examples. So, use A, B, and C to split up B. This is where we first start. We've got to break apart that middle term that we would have collected together when we finished FOIL, break it apart into the split that we need to factor this thing. So, step by step. First thing, write down what A, B, and C are. So in this case, A equals 2, B equals 9, and C equals 10. Next, you need to work out what you get if you multiply A and C together. So A is 2, C is 10, so AC equals 20. Many of the simple quadratics you find, A is going to be 1, so AC is just going to be the same as the value C, but this method works whatever the values of A, B, and C are. Now you're looking for two numbers that will add up to make B and multiply to make AC. So two numbers that will add up to 9 and multiply to make 20. The best way to go about this is to look at this number here, the 20, and split it into its factor pairs and see which one works. So 20 we can split up as 1 times 20, or 2 times 10, but those don't add up to 9. 3 does not go into it. 4 times 5 makes 20, and 4 plus 5 makes 9, so that is the pair we want. So 4 plus 5 is 9, 4 times 5 is 20. So what we're going to do is rewrite this 2x squared plus 9x plus 10. And instead of saying plus 9x, we're going to say not plus 9x, but plus 4x plus 5x. We're splitting it apart into the two bits using the split that we have chosen with this property. So we found two numbers that multiplied to make AC and added up to make B, so we could split B apart into them and write 4 terms instead of just 3. Next step is to make a grid. You want to draw out a 2 by 2 grid, and each cell in the grid is going to be filled with one of those 4 terms that we've come up with. If we've made the correct split, this will allow us to factor the entire expression. You'll need to have a row header and a column header, which I'm filling in gray here. Obviously, you don't need to fill in gray when you're doing this by hand. And the 4 cells of the table are going to take these 4 terms. So 2x squared plus 4x plus 5x plus 10. The x squared term will be top left, the constant part will be bottom right, and the other two go in either order here. Next step, look at the top row. We got 2x squared and we got plus 4x. Pull out the largest factor you can see from these two terms. There's always going to be an x coming out of it when we're factoring a quadratic. And check to see if there's any number as well. We got 2x squared, 4x, so hopefully you can see that 2 is also a factor of these. So 2x is the greatest factor we can pull out from here. Now we're going to move to the columns. What we want is that the header of each row and column, when you multiply them together, they give you the cell involved. So 2x times something gives us 2x squared. What goes here so that when we multiply these two things together, we get 2x squared. That's x. 2x times x gives us 2x squared. Same idea here. 2x times what gives plus 4x. And hopefully you can see that that is plus 2. 2x times plus 2 gives plus 4x. We have one final thing to fill in. Same idea. We want to say this times x will give us the plus 5x. What times x gives plus 5x? And the answer is plus 5. Make sure that you have the sign involved with each of these things. Okay, I've been careful to copy down plus, and if I had negatives, I'd be writing in a minus. Make sure you have a sign everywhere that there should be a sign. This bottom right cell we haven't used yet. We can now use it to check that everything has been done correctly. If we've got this right, then that plus 10 will be the product of the two final elements. The plus 2 times plus 5 does equal plus 10. That check means that we've got everything correct and we've finished factoring it. All that's left is to write it out. We write out the row header in one parenthesis and the column header in another parenthesis, and that's the end. 2x plus 5 goes in one parenthesis. X plus 2 goes in the other parenthesis. So we finished factoring. We can summarize what we had. 2x squared plus 9x plus 10 we have now factored, We split apart the 9x into 4x and 5x. We used a grid, and we found that the whole thing was 2x plus 5 times x plus 2. And if you try FOIL on this, 2x times x is 2x squared. 2x times plus 2 is plus 4x, plus 5x from the middle, the inner terms, and plus 10 at the end. 2x squared plus 9x plus 10.